here's what we've got. Okay, this is going to be like, everybody see that okay? All right. We have experience dealing with linear equations that we've seen since grade 9, okay, and a lot of grade 10 and discourse. We have also seen these quadratic equations, okay, and now you guys have become familiar with, or have seen at least, this exponential idea, okay, how quickly things like take off, okay. Our goal for this lesson is to figure out what x would be in the exponent such that 2 to the power of that exponent would equal 64. That's our goal, okay? They're not always going to be able to, like, you're not going to be able to look at the exponent and figure out what x is. We're going to have to be able, there's a method to solving for what x is, okay? And this is why we're doing this, because it's kind of good review for the exam, right? Just reviewing linear, like solving linear equations, and you'll see here come in a sec, okay? So an exponential equation is an equation where the unknown, okay, is in the exponent relative to your quadratic thing, which looks a little bit nicer, right? Or your linear one, right? There's no exponent there. So this looks a little bit more complicated, but really, you have the skills to do this. So I'm just going to teach you one more skill, and then you guys will be able to do it, okay? So the key to solving this type of equation is to establish a common base, right? And that's kind of been a common theme across this whole unit, right? We haven't been able to do anything unless, like, the bases have matched, right? And you remember, if I were to do this, it would be m plus n. I wouldn't be able to do this if the bases x and x did not match. Okay, so that's our goal here today, right? And you will have nice questions. You're not going to have to sit here and struggle. Our goal is to force each side of the equation to match so that you have the matching bases. That's our goal, okay? So sometimes, this is what I mean, sometimes these are kind of fun. So, for example, if b to the x is equal to a to the y, and a equals b, then x equals y. Okay, that's a whole bunch of mumbo jumbo. I get that, okay? It'll make more sense when we throw some numbers in there. You guys be like, okay, this makes sense, okay? So, here are the steps, right? You can write both sides of the equation with the same base. That's step 1, okay? Since the bases are equal, then the exponents are equal. Okay, we'll maybe revisit this list after we do a couple questions and make sure that we're okay. All right, and then solve the equations in the exponents. Okay, so here we go. I don't think I've made any really complicated ones, so we're going to be okay. So let's look at step 1. Our goal here, can't really do anything with the 2, right? But there is a way, and you guys should maybe do some thinking here. Is there a way that I could write 32 with a base? So basically the question is, I want the 2's to match. That's our goal. That's step 1. I want the 2's to match on both sides. Is there a number that I could put in the exponent here that gives me 32? Is it 5? Jacob says it's 5. Can everybody confirm that it's 5? Does everybody understand what I'm saying? Is there an exponent? Can I raise 2 to the exponent of something to give me 32? The reason why I picked 2 is because I have a 2 here. I want to match this 2. So I match the 2, and then I see if I can plug in a number for the exponent. In this case, 5. Right? Equals 32. So 2 to the power of 5 would equal 32. Right? Now you can say, okay, well, since the bases are equal, the exponents are equal. So you basically get to go, okay, I don't need the 2's anymore. You get x equals 5. Right? And you say, okay, we could solve, there's nothing to solve here, we have our answer. But that's it. You could confirm, if we went right back to the very beginning of the question, if I were to plug in x equals 5 into where I see the x, obviously for this question, because we know it's right, 2 to the power of 5 does indeed equal 32. Does that make sense? So the only thing that's going to change here is, like, the exponents are going to get more complicated. But the idea is the exact same. Okay? Next one. You identify, okay, I have a 3 here. Your goal is to rewrite 81 as a base of 3. So 3 to the power of what gives me 81 is your question. Okay, and you're by all means free to use your calculator. You sit there and you just try them. You try 3 to the power of 2, not going to work. 3 to the power of 3, not going to work. 3 to the power of 4. Okay? Oh, maybe 3 to the power of 4 gives me 81. Okay, so we're good. So 3 to the power of 4, this still has to equal the left side, right? So we're going to say 3x plus 1. Okay? You have now completed step 1. Both sides of the equation have the same base. Then you say to yourself, okay, now that the bases match, I don't care about the bases anymore, right? You could just rewrite the equation in the exponents. So x plus 1 equals 4. Solve for x. How on earth can I do that? You could say, okay, I'm going to subtract 1 from both sides, as normal as I've done a million times, right? As you guys have seen. So you say, okay, x equals 3. To check that, as per usual, you could always go back to the original equation and check it. Plug in the value that you got or that you found and see if it works. Well, 3 to the 3 plus 1 has, 3 plus 1 has to equal 81. So you can confirm 3 to the power of 4 equals 81. If it does, then you know you're right. That make sense? Okay? This is why I'm doing this today. Okay? There's two things going on here. Okay? I think this is kind of fun. B, you get a little bit more practice dealing with like exponential equations. And C, we get to review this, which I know is a problem for people in this class. Right? And will continue to be a problem if we don't try to do some more questions, right? Especially for the exam, right? That's my goal. Give you guys a little bit more exposure to this so that when the exam comes and I put the questions on there, you guys get some free marks, right? You can show me that you can do this relative to the beginning of the year if you couldn't, okay? So these are kind of fun. I don't mind these, okay? The other thing that goes on in here is there are some power law stuff that goes on, right? As you can see here, okay? As we move through it. So, step 1, write the base. 4 is an easy one with a base of 2, right? We're going to get 2 to the x minus 1. The left side's going to stay the same. But I'm trying to match the 2 on this side. Well, what do I have to raise 2 to the power of what? 2 to the exponent what gives me 4? Two squared gives me 4, right? Now that's 2 with the 2 above it. So now, here's the problem here, and this is what's new about this particular question. You can't get rid of the exponent. You got to rewrite it there. Okay? So, there you go. That's step 1 completed. You've rewritten the whole line so that the left side has the same base as the right side, right? And now you get to ignore the bases and just solve what's in the exponents, right? So we're going to get x minus 1 has to equal 2x minus 1. Now, this is a problem because this is what I mean. We're getting all sorts of good exposure here to things that we don't necessarily have great experiences with, right? Distribute the 2 in. X minus 1 equals 2x minus 2. Now I want you all to give me, basically we're collecting like terms, right? I want all the, I want the highlighter. I want all the x's on one side, and I want all the numbers on the other side. And remember, when you move things from one side to the other, you have to change the sign. That's because I'm creating 0 pairs. So I have to add 1 to this side, add 1 to this side. Take away 2x from this side, take away 2x from the other side. Those are the rules that you have to follow. Right? So your next line here would look something like this. I know I didn't write much room. I should fix this. X take away 2x has to equal negative 2 plus 1. I'll try to write it up here. Okay? You're going to get negative x is equal to negative 1. Right? Divide both sides by negative 1 because there's a pretend negative 1 here. So you divide both sides by negative 1 and you get x equals 1. Now you can 100% confirm that that is correct by taking x equals 1 and plugging it into where you see the x's. And you should get left side equals right side. Just like a normal check when you guys check stuff. So do we have any questions? It's the same, like you're going to follow those 3 same steps. The only thing that changes is the equations that are in the exponents, right? And so this is, again, it comes down to your practice, being able to solve these things. Okay? We'll do D. How much time we got left? We got some time. We'll go right to till break, and that'll be that. Okay? So left side's going to stay the same. You always kind of look at what's going on, and can you write one side as a common base with the other, right? So I know, and you guys should hopefully know because I made you write out that sheet, that something squared equals 9. What is the something? Right? You guys know we're just going to rewrite this left side. Now the question is, I need to write the 3's so that they match. So 3 to the power of what gives me 9 squared, 3 squared. Right? Now that you've got the bases match, scratch them out. Solve the exponents. Okay? You say, okay, 4x minus 1 has to equal 2. Give me the exponents on one side. Or sorry, the x's on one side and numbers on the other. Okay, well, add 1, add 1. 4x is equal to 3. Divide both sides by 4 to get x by itself. X equals 3/4. I don't think, and I personally don't think, this is 100% intuitive, right? I don't necessarily need to think I can look at, is it going to be see that okay? I'll zoom in. I don't necessarily think I can look at that right off the bat and figure out that x has to be 3/4 in order for that equation to work out. That's not easy. What's a little bit easier is just following this three-step process. Right? You just run with it. Okay? Do another one. This is a nice one. We rewrite the left side. And is there a way to rewrite 16 with a base of 4? 4 to the power of what gives me 16? 2. Good. So 2, we can write x plus 1. Now the bases match, so you can rewrite the exponents. 5x minus 3 has to equal 2x plus 1. And just collect like terms now, right? We're just going to start moving stuff around we want all the x's on one side and the numbers on the other. That's it. Okay? So to do that, I can add 3 to both sides, and I can take away 2 x's from both sides. And my next line would look like this. 5x, take away 2 x's, has to equal 2 plus 3. 5 take away 2 would be 3 x's, has to equal 5. Again, not an intuitive answer. That's a little bit tricky. Okay. All right, F's an interesting one. Now, I think, am I going to give you one like this on your test? Maybe not. I mean, you guys can do this. Is it harder than it needs to be? Maybe a little bit for you guys, okay? But we have the skill to deal with this. If you guys see something raised to, like, it's a fraction, right? So basically what you could do, you do one of two things. You could get rid of the fraction. How do we get rid of fractions? By playing around with the exponent, right? So we could say, okay, well, we could rewrite this question. Is equal to 125 to the exponent -1. Do we understand? So I like flipped the fraction. I flipped the fraction and made the exponent negative. That's what I mean. We all have the skill to do that because we've seen that a few times, right? And then your question can be, is there a way for me to write 125 as a base of 5? Right, so you rewrite this again. 5 to 2x minus 1 has to equal 5, right? This is the goal. I'm trying to get the bases to match. Can I get the bases to match with an exponent? Well, 5 to the power of 3 gives me that answer. Right? And you multiply by the negative exponent that's sitting there, right? So we basically get this. You can ignore the bases now, and you get the exponents are equal to each other. 2x minus 1 is going to equal -3. Solve for x. Well, you can add 1 to both sides. And you can go 2x is equal to -2. Divide both sides by 2. And you get x equals -1. A trick here. Just a negative exponent. Oh, you guys could deal with that. The important thing is that the 3 steps don't change. Right? It's the same thing over and over and over again. Okay? How about I'll do h, and then I'll stop the video, okay? Because it's almost break. Okay? One more. This one will be quick. This one here, although it looks a lot more complicated, we could do something right off the bat, and it would solve a lot of issues. I could divide this by 3, and what I do to one side, I can do to the other. Or I have to. It's not that I can. I have to. Right? The 3's drop out because 3 divided by 3 is 1. And you're left with 5x plus 1 to the exponent x plus 1 equals, what is 15 divided by 3? 5. That's convenient. 5 to the power of 1. Right? That's convenient. That's why I did that. So now you get, okay, the bases match. You can go like this. X plus 1 has to equal 1. Solve for x. We can solve for x by creating 0 pairs. Take away 1 from both sides. And we get x equals 1 take away 1. There you go. Done. You could check that if you'd like. If not, you can go for break. Okay? I'll stop the video there, and then that's that.